Hi everyone, it's Dave from the Alpaca Benro Polaris project. I'm here to talk about the version 2.0 driver, and what better way to discuss it but to demonstrate it. So I'm going to fire it up here. It's installed and run pretty much the same as the version 1.0. I haven't actually got the Polaris powered on yet. Before we connect the driver to the Polaris, we can have a look and connect Nina to the driver. And we need to choose the device. I think we'll choose this one here. And actually, before we connect, we've now enabled this settings cog button. If you click this, it'll fire up the Alpaca Pilot application and allow you to monitor in detail how the connection's going. So you don't really have to watch the log anymore. It's all done through here. Actually, the next step we have to do is it tells us here we need to check the power of the devices because there's no devices discovered. It uses Bluetooth low energy to discover if there's any devices nearby. I'm just going to turn it on. Yes. If you press the top of the red button, I've found it's more successful for some reason. Now, when it detects a powered on Polaris device, it'll list the device here. If you've got more than one, you should see more than one. You can choose which one. But if it just finds one, it will automatically try and enable the Wi-Fi of the device. If it's been successful, it will come up with a blue Wi-Fi signal here. And then if you've connected to the device previously, hopefully your Wi-Fi will eventually, oh, there it goes. The Wi-Fi will automatically connect to the Polaris, much like it did in the previous 1.0 version. It takes a minute or so for the network to be able to be accessed from the Alpaca driver, but it will keep trying, and there we go. I didn't have to do anything, but you can see that it's successfully connected, and it's picked up the hardware and software firmware versions of the Benro Polaris. You can see it's in photo mode. It's got a little indication that we need to change it to Astro mode. We'll do that. Switch across to Astro. And the other thing that's probably worthwhile doing, especially if you're using the L mount for your camera, it's often good just to hit the park button here to make sure that the mount gets into the home position. Let me just bring up a picture of the Polaris. You can see my lovely camera, piece of wood. Well, it's not going to take many images, but I'm just using it for a demonstration to see the angles. So we've connected. Now what we want to do is, normally you go ahead with the Benro Polaris application and do your compass align and single star align, but what you can do is you can skip these now. You don't need to do them, and it'll just use a default value. So it's assuming that this direction is 180 degrees, so that's pointing south. And you can also, so you can skip that, and then you can also skip the single star align as well. It uses the default of 180/45, so it's assuming that the device is pointing south and pointing this way south, and it's at 45 degrees in its home position. We won't touch multipoint. We'll come back to this in a future one, but you can still use it without multipoint. Now, the other thing you can access, as I said, you can access all the settings of the device directly from the Alpaca Pilot application and make changes within here. I can select a point on the map, and it will automatically update the location to Lavender Bay and get the elevation from a web service as well as the pressure, and fill in the latitude and longitude. So it makes it really easy to set your location of where you're observing from. So that's it. And also, if Nina goes and changes the location, you'll see it reflected immediately on this map as well. The other thing you can do is there's a few new settings which we'll talk about in another video. The main one to check is your advanced control features. Just make sure that can be disabled. Make sure we've got that enabled. We'll demonstrate some of these features, and you can save any of the changes to the settings. In fact, I'll save that, and we'll show you the dashboard next. It basically shows you the orientation of the camera and any activity on the motors. You've got the ability to switch between azimuth, altitude, roll, and right ascension, declination, and position angle. So you can just quickly switch between the two. This LST here is the local sidereal time. So that's like the meridian, and we're just pointing above the South Pole here at the moment. We're pointing south, we're at 45, Sydney's at 33 or something like that. You can park the mount, which is already in that location, so that doesn't really do much. You can stop the mount immediately, you can initiate tracking and turn tracking off. You can even adjust the tracking rate. These have not been implemented yet, but intentions to add these and potentially add orbitals as well, since we've got full control of the tracking now. Now, these radial dials are pretty flexible. You can change the zoom range. So this says it's 6 degrees from this side right across to the other side. You can also, if you're on a desktop, you can use a mouse to zoom in and zoom out, and they go down quite a fair way. So you can zoom right in and see just the slight movement down to arc seconds of the device. It's pretty very, very accurate anyway. You can click on a scale. So if we zoom back out again, I can say if I want to move the mount to 150 degrees, I can click on that and away it moves. And I can bring it across to point directly towards us. There we go. It's pointing directly at us. And you can change the altitude as well. There's nothing really that new here, is there? Except for the roll. Now, you can tell it to do a 30-degree roll, and it will calculate how it needs to move to get into that position and maintain the azimuth and altitude that we're at before. So it's still pointing at us, but it's got well, it's not really a camera, it's just a piece of wood so we can see the angles easily. It's put it on a 30-degree tilt, and we can go 30 degrees the other way, and it automatically works out how it needs to move the first motor, the motor 1, spinning around to the other side, and it should point to us and give us a 30-degree or even up to a 60-degree. There is a limit. You can't really get down to 90 degrees very easily, but it gives you full control of that. And the other thing you'll notice here is I can change each of these on the fly. Now, go back to 0, and all of those three will be picked up, and the green arrow points to where it's trying to get to, and it'll work out the best way to move the head to that location. We'll come back to pointing directly at us. Isn't that cool? With the alpha version, just be wary of going down to an altitude of 0. There is an issue with gimbal lock still. It can get a bit confused and have issues. So there we go. The other thing that's in here is a whole bunch of performance tuning. On another section, we'll talk about our single point alignment and multi-point alignment, and the different ways you can add sync points. And there is a calibration suite of tests to help just calibrate the tuning parameters to your particular mount. Don't have to use it. I think the current settings are probably satisfactory. You can come in here to the Kalman filter. You can see here it's pretty noisy, the information that we're getting back, and what this does is it tries to smooth out and get rid of a lot of the larger peaks. It allows you to quickly test a nice little slow movement and see how those do. PID filtering isn't active yet, but it's coming. You can do some tests on the pulse width modulation tests, and we've got some pages for looking at the individual coordinates, and even the driver log is available within the application. I forgot to mention on the settings, whenever you make a change here, it's immediate. So it's actual live to the device. So you don't need to save to send it to the device. This is just making it persistent. So if you make a change here, it will be immediately effective in the driver and in the device if need be. The other thing that we've added is a catalogue, which is searchable. So if I wanted to find the first star I would typically try and point to would be Rigel Centaurus. I can just type a few letters and it'll come up with the star in Centaurus, and I can see here it's at a nice altitude, it's high in the south, and I can just click this button and it will immediately navigate to that location. In fact, if I fire up Stellarium, let me just get that running. So if we hit Control-0, we can go to our telescopes that we've already pre-configured. I'll just connect it, and there we go. If I click on that, I can make that the center, and you can, of course, we can also select and navigate directly from Stellarium as well. It makes it really easy. If we want to say, let's just confirm that we've got the same sort of coordinates. Looks like the Carina Nebula, that's probably going to be fairly high. Yeah, it's the second one that's available in the southern hemisphere. I'm going to go to that, and we can watch it on Stellarium, cut across to the Carina Nebula. Allow us to do some imaging there. You notice that I was doing all these GOTOs, it didn't actually turn on the tracking. You need to, it will preserve whatever the tracking state was when you do GOTOs. So I can actually turn on the tracking, and if I wanted to look at, say, another, let's find another one that's close by. How about the, actually I know there's one here, the running chicken one. Oh, there it is. That's pretty close. We'll go there. Actually, it's just up here. You can see I did that even with the tracking was enabled. I was able to issue it, and if you actually zoom in on it, in fact, we'll pick another star nearby and go across to this one, and look what happens even when you get really close. Which one did we pick? I can't remember. Does it say this one? This one? It's very hard to see. But I picked this one here, and you'll notice it's not doing that little backlash dance. It's sort of zooming in and getting closer and closer to that particular item. Let's say pick this star here. Come across, and we're zoomed in pretty far. And because tracking's on, it should basically be following this star. So I'm going to make this guy the center of the screen, and you can see the tracking here. You can see the azimuth altitude grid, which is the red grid. It's moving away, and we're getting closer and closer, and once it gets on that star, it should basically track it, which is pretty close. But the ability to fine-tune it is what the pulse guiding does, and I'll just demonstrate through some slewing. So I can actually say, well, I can try again with the GOTO, it'll probably get it, but look, this is a bit off here. And when I think about where this is in the sky, here's the South Pole, So it looks like it needs to come back in again. It looks like it needs to come this way, which is slightly ahead in right ascension. So I can switch across to right ascension here. And if I zoom in, depending on whatever zoom scale that you've got here, this is how fast it's actually going to move through the device. So I've zoomed right in here. Let's make it say 10-minute scale, and I want it to move forward, increase the right ascension. Let's see what happens here. Oh, that's a bit fast. Let's go in further. I really went zoomed in there, didn't I? Let's come back. Bring it back. And a bit more. And a little bit more. So you got really fine control in the right ascension, declination, position angle, whatever you want. You can actually control the set point directly. And here, actually I'm going to come, am I going the right way? Actually I'm going away. Let's come back just a little bit more. You can get whatever framing you want. It's really very accurate, and it's pretty good at tracking. It's I think there's still some further possibilities for improvement, but I've been pretty pleased with the re-implementation of the tracking algorithm, the ability to really fine-tune it without having to do the little jiggle that the Polaris used to do. So that's a pretty quick summary, demonstration of some of the major features in the Alpaca Pilot and in the driver. And what we'll do in upcoming episodes, I will demonstrate each of these functional areas in a bit more detail and go through some of the details in the settings and how they affect the driver, how they affect the Polaris, and how you can get better imaging out of it. So look forward to hearing feedback and helping us improve it over the beta period and getting it released before the end of this year. I'll see you later. Bye.